So I'm going to talk about what we call small AI and why we think it's a pretty big deal in RPA. But to kick things off, just a few words of myself first. I've been working with the software for over 20 years. I mostly enjoyed my life in small companies, although I made a few tours in big ones. But always after, let's say, 9 months of a life in big company, I returned to the small company, and now I'm again in a small environment. I started my career as a database developer. I was actually Oracle databases for a telco, but I got into project and product management quite soon, as well as sales. And then I would say a couple of the proudest moments of my career, like early career, has been to manage a project where we deployed barcode scanning capable Palm OS handheld devices. That was about 20 years ago. And we were automating the reporting of home care work in Finland. And at the time, that was actually the largest mobile solution in the country, which is pretty cool. And then later on, I was working for Nokia's consumer insights collection from their devices and running that kind of a pretty big project. Today, I'm a chairman of and CPO of Aito AI. We're Helsinki-based machine learning startup. We founded about 2.5 years ago. And despite our young age, we've had a pleasure of working with companies like IKEA, Comcast in the US, and Posti, which is the national postal service in Finland. At Aito, we provide intelligence, like the brains, for robotic process automation workflows. And like the previous presentations, they were not so much of an RPA or process automation as we see it from the software side. I think the first presentation was the closest we encounter document understanding and document extraction quite often, and it's typically a part of the flow where we work too. I'm not going into details of what RPA is. I'm kind of assuming that the basics are there. At simplest, you can ask a question if you can write a process guide of something, and if you can, it's most likely that you can also automate it with the software robot. It can be a task or process, and if you have less complexity, then it takes less effort to develop the automation and at the less cost. You add complexity, the total cost of not only the developing the automation, but also the maintenance shoot up quite drastically. And there's like a limit where the development and maintenance of an automation becomes more costly than the actual benefit that you get out of it. And rule-based automation, so simply writing everything in if-else rules or a written documented logic, it has a cap how far it can extend. And obviously, what the market talks about at the moment is intelligent automation, bringing machine learning into the equation with a promise of moving the complexity cost chart in the pseudo picture here towards right. So we can reach the higher level of complexity with less cost and push that limit of too complex further down to your roadmap. But I think there's a caveat, and not all machine learning is equal in terms of applying machine learning into RPA. There's a machine learning scene or machine learning projects which can be treated as science and research, and then there's the opposite end where you can treat the machine learning project as a software development task, which utilizes APIs and tools that are they take away a lot of the complexity that comes with deploying models and operating like a state-of-the-art machine learning. While tackling big problems with a crew of data scientists, it might bring big impact to the business. But I don't believe that's the right way or the only way to apply machine learning in RPA workflows. It's too an easy way of ending up in the statistics as a failed AI project. And you all probably read those statistics that I think that was Gartner or somebody else who said that 85% of AI projects are failing, and those numbers change every year, but they're still there. I think it's important while we talk with RPA teams in organizations is that I still haven't met a company that could not reap the benefits by being small instead of risking with the big projects. So that's why we are talking about how to operate in that zone, which is shown with the arrow, high efficiency, and get things going with super simple efforts and agile methods. You can look at the same kind of a thing from another angle. This is a recent study from Algorithmia, 2020 study. How long does it take to put a machine learning model into production? There's a bunch of people who can do it in less than a week, but all in all, the rest shows that it takes way over a week on average to get a machine learning model into production. While there's of course problems that definitely warrant the investment and time and the resources, there's also a lot of use cases which are rather small. So take predicting a missing data point of a purchase invoice to file it into accounting. You might have used the document extraction first, but they're not perfect, they're not 100%, and so it's none of the machine learning. You can match an order confirmation contents with the right order in SAP, for example, or you can decide if an automatically generated invoice is good to send to customer. So these are all like super small problems, and the one process that you try to automate with tools, software tools, might even include several of these machine learning encounters or predictions within the whole flow of the process. And I don't think they should be considered as a project of their own, but they're increasingly just a part of the normal RPA development workflow. So what does starting small problems, what does it mean? What are the benefits? Based on the discussions with the RPA team leaders and RPA practitioners, I think there's like three main benefits in play. First, by keeping the approach small, it means that the RPA team can actually handle a lot of the things without engaging with a usually separate enterprise data science team, which is managed in a different way. It's not the same team. And actually one of the RPA team leads called their own enterprise data science team a black hole, where all of the ideas get lost for months. And I'm obviously not going to reveal the identity of this person, but I think it was a very fitting comment. The backlog wait times for getting things done are quite long many times, and the enterprise AI teams, data science teams are extremely busy with the problems they are solving, which typically are the big ones like Alec was just explaining. Second, by using the tools that allow RPA developers to build the intelligence, you can keep the team small and nimble. This team can continue to work with their favorite agile methods. So if you look at the typical model deployment times in the previous slide, compare it with how many of the RPA teams work with few week sprints and get things done really quickly, you lose that agility if you need to work according to a data science team's schedules. And third, you can avoid costly maintenance in the form of retraining, deployment, optimization of the models by choosing the right tools. And the high impact and return on investment comes from being able to efficiently implement more and more complex automations without significant cost increase from the actual work that you need to complete those automations. So where do we find these platforms? What are the tools to use? This division is completely my own and it's very rough. And the market moves so fast that I think you can basically invent any type of classification of ML and AI tools, and most likely, you can justify its existence. I made this, so I'm just using that one for now. If you start from the left, there are machine learning ML or machine learning operations platforms or data science platforms, however you want to call them. The main reason of their existence is to make the work of a data science practitioner's that workflow easier. They deal with features, maybe feature storage, algorithm discovery, model evaluations, version control, model deployment, hosting, and so forth. I bet every data scientist on the call has used some of those tools. You can take Dataiku, you can take even let's say UiPath's AI Fabric somehow falls into this category, as it allows you to maintain the whole workflow and from a data to a prediction in one platform. Then second, from the left, is automatic machine learning platforms. And here I count platforms that help run like hordes of algorithms against the same data set. So it tests all the possible algorithms coded in the platform, even makes an ensembles out of those, and then chooses the winner based on the given criteria. And does then maybe a bunch of workload management around the process. Maybe one of the established players would be H2O or Data Robot in this segment. Then moving right, the machine learning APIs, which are meant for predicting one type of an outcome. Usually, it's packaged in a neat API, and sometimes comes with pre-trained. The model is pre-trained with vendor's own data set. And you can, in some cases, further train it with your own data. But the point is that it kind of comes ready for use over the API. Especially the topic of the first presentation, the document extraction, has seen a lot of these APIs popping up in the recent times. AWS has their Textract. Google Cloud Platform has something called Document AI, if I remember the name correct. So you can use those to extract entities from for example, PDF documents. There's Google's AutoML natural language processing, which is a neat API for natural language. And then on the last right side, there's a newer category of predictive databases or in-database machine learning. And that's basically allows predictions to be run using queries that extend the typical database query language. So database query language like SQL is used by probably millions of maybe tens of millions of developers globally to extract data from the database. This same logic of query and response can be extended to cover also machine learning predictions. The benefit here would be that the data and predictions live in the same place, making the software stack super simple, efficient, and it's particularly suitable for RPA users' needs. In this category, there's a couple of players. Obviously, you probably guessed that Aito AI falls into this category, but we're not the only one. So there's companies. Oracle has their OML, Oracle Machine Learning. Google has BigQuery ML that runs predictions in the database. So this is exactly where we are too. And I believe that the small lives in those APIs and the predictive databases. That's the area where the RPA developer finds the tools quickest to deploy to their use cases. So what does the small and efficient look when in use? I took a couple of screenshots of this is my own test bench in UiPath. Why UiPath? It's simply because it's quite well used in the Nordics. Our customers are using UiPath along the other tools. In our vision, the easiness means that the usage is integrated into the RPA platform, but the machine learning is integrated into RPA platform, and it relieves the developer from even thinking what to do with the model, and you don't need to consider a model's existence. Essentially, adding new data becomes a action. Like in the picture, it says I to add new data, which pushes new data points into the database. And on the other hand, there's a predict actions within the workflow, which they curious the right prediction from the predicted database or in database machine learning, and all the rest is handled by the platform. And today, some of our customers use, as mentioned, UiPath, Automation Anywhere, Blue Prism, Robot Framework, a couple of other platforms, and even just from the Python code to do this already. And I think I'm going to stop here for a second more. There is one thing that we encounter quite often when talking with the RPA teams, and it's the fact that where does the training data come from in terms of when you start automating a new process, where do you get the historic data to train for example, if you talk about matching the order confirmations to your SAP entries, where does it come from? So that is something that can be quite easily solved by this type of approach, where you can drop a data input action, start accumulating the data from the flow. You don't need to access all the historic records in any of the services. You don't need to deal with the corporate IT in that sense. So that injection of a data addition to the database does it automatically. Once there's enough data, we can start automatically then predicting. And it really works well because there's usually a human in the loop version of the process needed anyway, because none of the machine learning predictions are like always correct. So there needs to be the flow of human helps and checks, human doesn't help, and everything's automated. So working this way, that you start collecting the data from the process and then predicting when everything's ready, is a rather neat way of getting the automations working. So what's happening then in the background? We're not going to have a programming lesson today, too little time for that, but I just want to show you what does Tommi do in the background. So what we've done is to take, it's actually like a MongoDB style query language. If you use SQL, you see see a lot of the familiarities here too. But basically these kind of queries bring those predictions into life, and basically in this case, for example, you have the purchase invoices in the database, and you predict the GL accounting codes from it very easily. Either does it in a few hundred milliseconds. Why this is important? The last slide, I was given a 1-minute warning. So I draw a customer quote here, as it is not as much about ITO, but it's about the way of working and the new tools. So Posti is the National Postal Service in Finland. They used ITO to automate their purchase invoice processing. But I think just not looking at the use case only, the beef here, in my opinion, is the transformation of the team. So they can see a lot more opportunities in their automation work, like a roadmap, by being able to deploy machine learning using their RPA developers. And once you have that capability, you basically start seeing the use cases almost everywhere. There's like a lot of small use cases that you can automate. And that's my story today.
Thanks so much. That's a great picture of tools. I liked it a lot. Thanks so much, Tommi, for walking us through. What's the last message here? Free 3 months for any instance with code anymore?
Yep. While you guys are typing all the questions, I can also promote that use the AI Monday rules promo code. You can get a 3 months free ITO instance from our website. So you can go and try your own use cases.
Ah, nice. Yeah, we actually don't have much questions yet in the audience, so feel free to drop them into our Slido or into the chat area here on the stage. But nevertheless, I think quick question on my side, right? So what we realize was the many discussions that we have is that often it's about it's kind of the main challenge is to kind of get the different people that are not super familiar with machine learning as such, right? With the necessities around doing this to actually kind of make the transformation from like, this is my business process and I'm knowing this process quite well, to what's possible on the AI side in terms of automation. So how do you handle that type of problem when you get into that? Is there already kind of a certain level of knowledge available, or is it something that you struggle with as well to kind of?
I think it's a really valid question and really valid maybe a challenge, not the problem. Like our work is mostly done with the RPA team within the enterprise. So typically, then if you look at the RPA team's responsibilities, they would be selling, they would be working together with the process owners within the corporation, and those projects are implemented in some kind of a cooperation between the process owners and the RPA team. what we bring into table for those RPA team members is that they can basically make a like a predictive or intelligent automation super quickly, and they can show that, you know, using the data sets that we have today, you can predict the match between the order confirmation and SAP order entry with the, let's say, 90% or 80% of the times. And I think by them being able to show that like early on in the automation project, it basically allows the RPA team and the process owner to discuss about the whole functionality, because it really is that automation does everything. There's always a fallback that what if the prediction is not, like the probability is not good enough, then you need to fall back to human process. So I think by bringing tools that give you the predictions like right away, and you can like just run an evaluation using our tool saying that with this data set, you can predict the missing data point 80% of the time or 60% of the time. Sometimes it might be way less, 40% of the time. And then the dialogue of how the automation actually works becomes way more kind of practical and close to the what the work actually will be then later on, instead of waiting for a long time for those predictions.
Cool. I just have also one question. Maybe it's associated to this one. Since you're running this platform, I think there might be a time when you collect a lot of process data and tool-related topics that you might not even have a human trigger anymore, right? So the system says, okay, you're having this system, you're having that system, you know, I have the right automation template for you, just try it and go, right? I mean, is that the mid to long-term vision also for you, or?
Like from our side, like I think there's so many companies working on the actual RPA platforms and RPA tools. Like we're not covering that. We are like vendor independent. So any RPA platform user can use either using simple HTTP code or activities and plugins that we provide. So I think from our perspective, we will be hitting the other prediction markets or other like developer markets than RPA at some point. So there's like a lot of things that happen where the predictions are made using Python code or whatever code. So I think we see our business being not only automation, but it can be a lot of other use cases for machine learning. So we intend to be a machine learning company, not a like an automation company.
Okay,